In question 27, we have a rather difficult question in which we have to deal with the geometry of a cylinder, because we're told that an open cylindrical container made from sheet metal of uniform thickness has a mass of 800 grams. We're then told that when it's completely full of water, the total mass becomes 15.6 kilograms. We're then asked to work out what the total mass of a container made from the same material in terms of its thickness, but double the diameter and double the height would weigh. So, what's the total mass if we double the diameter and double the height of this cylinder? So in this question we need to understand how the mass would change by changing the diameter and the height. So obviously when it comes to the water, we're going to be dealing with the capacity or the volume of the cylinder, so that's the thing that will be changing. When it comes to the raw mass of the container itself, we'll be dealing with, since we're not considering thickness, that will stay the same. The change in the surface area will indicate the change in the mass of the cylinder, whereas the change in the volume will indicate a change in the water contents of the cylinder. So we need to assess how the surface area changes and the volume changes by doubling the diameter and the height of our cylinder. So we should know the relationship when it comes to a cylinder of a certain radius and a certain height. We should know that the surface area can be expressed by saying that it's going to be the surface area of these two circles, which is 2 times pi r squared, radius of the circle, 2 times that, plus the diameter, 2 pi r, multiplied by the height. So the circumference, rather, as opposed to the diameter, excuse me, the circumference, which is the length all the way around the circle, multiplied by the height. So if you were to roll out a cylinder, the surface area of the middle section would be the circumference multiplied by the height. So 2 pi r h plus 2 pi r squared. So that's what the surface area would be under normal circumstances. So we can rearrange that by expressing it in terms of diameter, since we're going to be doubling the diameter, and radius is just half of diameter, so we can express it as 2 pi r squared as pi d multiplied by radius, d over 2 squared, and we can express 2 pi r h as pi times the diameter, h, since again radius just equals diameter over 2, and we're going to be doubling the diameter. So we can write that in a more simple format, pi d times d over 2 plus h. So we're going to be doubling our diameter and we're going to be doubling our height. So let's plug in our doubled diameter and our doubled height. So instead of d we'll have 2d, instead of d we'll have 2d, and instead of h we'll have 2h. Now if you were to realise that we have 2 outside of the brackets and we have 2, we're multiplying everything within the brackets by 2, we should realise that we have essentially 4 times the conventional surface area by doubling the diameter and doubling the height. So we have 4 times the surface area by doubling the diameter and doubling the height, and therefore the mass of our raw cylinder, which started off as 800 grams, we can multiply by 4 to give 3.2 kilograms. So that's the new mass of our cylinder. Now let's think about the volume of water, given that the thickness will remain the same, but the shape of our container will be changed because of the change in the diameter and the change in the height. So what's the volume of a cylinder? So that's just going to be the cross-section multiplied by the height, the cross-section area rather, so the cross-section area is pi r squared, and we multiply that by the height, h. Now we're going to be doubling the diameter and doubling the height, so we just need to plug in 2r and 2h, so pi times 2r squared times 2h, multiplying through, 2r squared gives 4r squared multiplied by 2h, and that gives us 8 times the conventional volume formula. So by doubling the diameter and doubling the height, you end up with 8 times the volume, as you originally did. So we need to multiply our water mass, which is 15.6 kilograms minus our 800 grams of the actual mass of the cylinder, by 8. So our water volume in the original was 14.8 kilos, and we need to multiply that by 8. Well, you can do this in the long form, where you can just say that 14.8 times 10 is 148, and you need to subtract 29.6, which gives you 118.4 kilograms. So we have 118.4 kilograms as our new water mass, and we have 3.2 kilograms as our new cylinder mass, so we just need to add those two together, and we end up with 121.6 kilograms as our final answer, which is option B. So this is quite a tricky question in which you really need to understand the equations associated with a cylinder. So these are things you need to bear in mind going into the BMAT exam.